Okay, so what do we do when we've got all of these terms? So when we've got highest powers from or when we have infinity, the highest powers rule. They really dominate or make it happen or not happen. So let me just show you what I'm going to suggest. You take the limit as x goes to infinity. You take the highest powered term with its coefficient from the numerator, and you take the highest powered term with its coefficient from the denominator. Oh, look at that. We're in a situation where we can cancel. So limit as x goes to infinity. If I cancel the x's, I would get a 1 over 3x squared, and that gives me 0. So let me show you another way. I don't think you'll prefer it, but just so you see it. So one method says to, let me write the problem down again. 3x to the 4th, 2x squared minus 1. It's the method says to multiply numerator and denominator by 1 over the highest power of x. So that would be 1 over x to the 4th. So then I go through and I do that. Limit as x goes to infinity. So I would take this x squared times the 1 over x to the 4th. So that would give me 1 over x squared. And then 1 over x to the 4th times this, that would give me minus 1 over x cubed. And then plus 2 over x to the 4th all over. Let me do that same thing down here. We take this term times this, so that would give me a 3. And then this term times this, I would get a plus 2 over x squared. And then on this one here, I'd get a minus 1 over x to the 4th. Now let your x's go to infinity. So in the numerator here, I would have 0 minus 0 plus 0 over 3 plus 0 minus 0. That's 0. You get to choose. Which would you prefer to do? This method or this one? I'm going to always use this one. All right, let's try this one again, or try it on another problem. So I'm going to take the limit as x goes to infinity, and I'm going to take the highest powered term, so 4x squared over 3x squared, cancel the x's, right? With limits, if you get infinity over infinity, which I would, you're always looking for canceling. So those x squareds cancel. Oh, I don't even need to write limit anymore, do I? I can just say this equals, because you cancel the x squareds, it equals 4/3. So just 4/3. So this one here, I want you to be smart. I know you are. I want you to be thinking about what would be the highest powered term in the numerator with its coefficients. So thinking about the 6 times the x to the 5th times the x, the highest powered term in the numerator would be, 6x to the 6th power. Think about in the denominator. The highest powered term would come from those two multiplied together. So that would be negative 2x cubed. Cancel, because if I plug in infinity, I get infinity over infinity. So I get limit as x goes to infinity. So I'd get so these two numbers here, right, this and this, give me a negative 3, and then I'd have x to the 3rd. And so now if I plug in an infinity, multiplying it by negative 3, I'd get negative infinity. So these numbers really matters. So let's try it again. So this one's going to negative infinity. We just need to remember to carry it along. So from the numerator, the highest powered terms would be negative 9x squared. In the denominator, these two multiplied would give us the highest powered terms. So that would be 5x to the 4th. Cancel, because we can. Go into negative infinity. And I'm just going to pull this negative 9/5 off to the side. And I cancel those x's, and I get an x squared in the denominator. So if I take negative infinity and square it, that's infinity. 1 over infinity, that's 0. Let's do yet one more. Limit as x goes to negative infinity. So from the numerator, all three of these multiplied together would give me the highest powered term in the numerator. So I would get a negative 24x to the 4th. all over, let's see, here and here, I would get a 20 x to the fourth, and that the x to the fourths cancel, so I just get negative 24 over 20.